Hello and welcome to this video on the introduction to Phase 5. Phase 5, actually I brought in some code that I was going to leave until Phase 6, but for want of creating a more functional emulator, I brought it in now. The major changes within the code. So in the address file, I've added code to actually set the status register, so that's a reusable code, and as you can see it sends in a char, which is effectively a short integer, and it uses a case of 1, 2 or 3 for the A, X and Y registers, and that's referenced from inside of the instruction file idinst.c. There's also the addition of an assembler. Now I will go through this. It's not actually an assembler; it's a disassembler I've written, but I've called the file assembler because I might write an assembler later. I will put a separate video together on this, and I will demonstrate it for you in a short while in this video. Inside of FSM.c, FSM.c has had a few changes. We've added a step routine under the execute, so we had this originally within one of the earlier phases, phase 3 or so. Where it would just single step through an instruction. Well, I've added that back in under the S command, but I've also left the go command in there, which does exactly the same thing, and I did start playing with things like keyboard handlers and screen handlers. I've not quite made my mind up how I'm going to deal with those yet, but that's one of the changes. The other change was we moved the reference to the 0x, so whereas originally in here for doing things like memory dumps we had to do things like 0xC00, we don't have to do that anymore. The reference doesn't exist anymore. We've taken hex as default, and we can just type in the start address like that. So that's another change. The monitor, the memory dump that is now displaying a more standard where is memory dump, where we're looking at display memory, there we go. So this now actually presents the hex code in rather than going with the address down the left hand side and then the single hex code. In fact, that's just a quick demonstration. So if we do a memory dump on C000 to C00F, there you go. So now you can see that you would expect, this is how you would normally expect to see it. So C00 there, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12. Sorry, 8 A, B, C, D, E, and F. Yeah. So that's a lot more standard. The other thing to note as well is that the status register flag for the negative flag is now also correct. Not before time. The instruction.c file, this here is now pretty much fully complete. It's not fully tested, by the way, but each and every instruction is written, and that's reflected in the memory config file. So I've started adding routines to do all sorts of nice bits of code, and I will put another video together to demonstrate how this works along with the step instruction, and how I did troubleshooting and debugging, and how I go through the whole sort of, is my code working the way that I would expect it to do, given the fact that this, although I'm sort of calling it 6502 emulator, I've been a little bit loose because I'm not emulating it to down to clock cycles and things. I'm more interested in having a look at the at how the instructions do what they do, and being able to make something that approximately represents the 6502 inside of software. The FSM, oops, I've just closed that, but it doesn't matter because there wasn't many changes in the FSM.h file. The FSM.h file in reality was the only difference really with the FSM.h file is that I've added these forward lookups, but everything else is pretty much the same as it was before. And there's now the structure is in there and things like that for the CPU. And we've taken into account that there might be clock timings coming in later, but at this moment in time, I genuinely really not bothered. So let's demonstrate some of what we've got. So obviously the help file, the help command now reflects what we can now see, and you've seen the memory dump. The memory dump now displays the hex bytes. The machine code actually is what it would be. proper format. But we can also, if we go into, I'll tell you what, let's go into, where are we? Let's go into the memory file here, and let's disassemble the C20F through C215. So if we go in here and we say disassemble C20F through to C215, what you can see here is that now we've got something that's a little bit better to look at for us as people. So here I've annotated what it should be, and here reflects exactly what you would expect to see based upon those hex opcodes. So you've got two choices. You can either look at it as hex code as we've been doing all the way up until this point, or now we can actually disassemble it and actually look at it as how you would expect to see it as assembly language. And that's pretty much why I've done that. It makes it easier to read. Certainly it makes it easier to make sure you haven't made any mistakes. The other thing to note is it is little endian, and we can demonstrate that. There's a bit of code up here somewhere. Yeah, there we go. And absolute, for example, where you've got this low byte and high byte and things like that. So we have a look at this now, C004. Oops. So if we go into, if we do a disassembly on C004, and we'll go to C007. And you can now see two things. First of all, note that little endian is correct, because the A1 and the B0 are back to front, but on the actual the assembly language output within the disassembler, they're presented to you the correct way around, and that's correct. That's the right thing to do. It's the way you would see it. It's the way you would write it into an assembler, and it's the way you would expect to get presented to it within a disassembler, because that's getting more and more high level. So this is the high level representation of this, or higher level representation of this, I should say, and that's how you would see it in any example that you would say, that you would get off the internet nowadays, or within books or so on. So that's pretty much it for this this video. I hope it's been quite a useful introduction. The next video will probably demonstrate the step routine and how I went through the debugging, and then later on we might do some more stuff and have a look at how the disassembler actually works, because I did write two versions of that, and I think it's probably worthwhile going through what that does and how it works, and how the instruction set is decoded. So yeah, I think for this video that will do.